Wow.
See those sparks?
Yeah. They're big.
Yeah, they sure are. Okay, now I'll turn the lights on so we can turn the machine off and we'll investigate. This is called a Van de Graaff generator. And have you ever seen sparks like that?
No, not like that.
Well, no, not quite that big. You've certainly walked across the rug, though, and then touched something, or like a brother, and give him a spark, and a nice little shock. Well, this is basically the same idea. If you remember, if you've ever done experiments with static electricity, you rub a balloon on it, stick it on the wall or something.
Yeah, or your hair and it sticks.
Or hair and sort of sticks up, yeah. And you can rub a hard rubber comb with a piece of wool, and then I don't know if I can give you a little tingling, you can feel it just a little bit. But that's basically the same idea. That's what that does, only it does it with a motor.
Oh,
so let's take a look at it. Underneath is the motor.
Oh, okay.
And when I turn it on, well, we spin it around, and this pulley goes around and turns that rubber belt. And then extra electrons are actually put on by these little wires here.
Oh, I see.
From the current. But the important thing is the electrons get caught on that belt and are carried up. See, it goes all the way up over to here, up inside this dome. So if we take the dome off, I think you'll get an idea of what's happening.
Oh.
See the other little wires in there with all those little points on? As the electrons come around on the rubber, they're picked off by all those points. And then they can flow over here through these wires. And there's a little piece of metal that connects the wires to this dome.
Ah. Okay.
And notice that when we wanted to collect electrons like that, we had little points. Now when we want to store them up, we don't want points. We want nice rounded kind of things, and that's why this is a sphere. So eventually when we turn it on, we fill this whole sphere with electrons.
Oh, I see.
And they're building up bigger and bigger and bigger. And then when I bring this dish over here, which I have turned upside down, the electrons jump from there to here. And I made this round also so that they would build up to the greatest potential before they jump. And that's how we got that big spark. Now remember, just to show you how those points work, here's another variation of a famous, you know how a lawn sprinkler goes around with the water spurting out?
Yeah.
Okay. What should happen if we put this cork up on top here, and that pin goes all the way through there? In order to put the top on, I have to put my glasses, because I have a little tiny hole in that wire so that I can balance the wire on top of the needle, like that.
Okay.
Okay, now the electrons are going to build up here, and they're going to flow up here through the pin and out over here. And see that point right there?
Yeah.
So that's where they're going to be sort of spit out.
Oh, I
So what should happen if we spit out something in that direction? What happens with the water hose? Or
It
the water
turns.
sprinkler? It turns. As the water comes out this way, the sprinkler goes that way.
Yeah.
Well, when electrons come out this way, what should happen to that?
It'll go that way.
Yeah, the other way. All right, well, let's try it. Watch.
Wow, that's neat.
You notice how the little strands go up too?
Yeah, just like hair.
Yeah, well, they're filled with electrons too, and they're
It's going fast.
yeah, it's going pretty fast. Every once in a while, I get a little shock coming from it. But don't worry about it. If you should feel a shock, because it's not very, it's high voltage. And in fact, you can make a rough estimate. Scientists ordinarily think in normal dry air, 1 inch, you know what an inch is?
Yeah.
I know you do in meters, but an inch is about 25,000 volts.
Wow.
So we had at least 2 inches, maybe a little more, so we had at least 50,000 volts.
That's a lot.
But it's very low current, so it won't hurt you, but you'll feel it. Okay. Now, probably the most famous of all experiments with a Van de Graaff generator is they get a girl who has nice hair like this, and they put a platform on the floor, and if you'll notice in front of you is a platform.
Yeah.
That I've made that with a bunch of bottles, so that's glass, so that's an insulator. If you step up on the board, go ahead, go ahead, step up on the board, you are now insulated from the floor.
Okay.
Okay. Now we turn on the machine, but first we put your hand on it like that.
Okay.
Extra electrons on the belt are going to come up here. They're going all over the sphere. And now because you're touching it, some of those extra electrons are going all around over you. And you remember how the little red things went up?
Yeah.
With the thing going around?
My hair.
That could happen to your hair.
Okay.
Now, it depends entirely upon what kind of hair people have and how much oil there is and what kind of a day it is, but we'll give it a try just so that you can say you've done it.
Okay.
Once I turn it on, then you shake your head like that to separate it. We'll see if we can't get some of the hairs on your head to stand up.
All right.
Ready?
Okay.
Okay, here we go. Don't take your hand off. Leave it on there at all times.
Okay. I'm tingling.
You're tingling?
Yeah.
Shake your head a little bit. Ah, some.
Should I shake it again?
Yeah, stay there. Keep doing it. Here, can you see yourself?
Oh, yeah.
How do you look?
Weird.
You're kind of weird. Shake it
Yeah.
again. Okay, now hold still once, and we'll just let it sit there for a minute.
Okay.
Yeah, the whole front's standing up.
Oh, okay.
Okay, now don't take your hand off.
No.
I'll turn it off. Don't take your hand off,
Okay.
because you're all charged with all those things. In fact, your hair is still standing up. Okay, now take your hand off and don't put it back on again. Take your hand off. Okay. Now step down. Oh, the minute you touch the rug, down went your hair. Okay, so you've done the famous Van de Graaff hair standing on egg experiment. And you safe and sound?
Yeah,
You're all
I'm
right?
fine.
Thank you. Lila, here's a quick little puzzle for you. Okay. I want you to be able to pick up both glasses from the table using only the balloon.
I think that's impossible.
Well, it sounds like it, doesn't it?
Yeah.
Okay. But you can do it.
Okay.
I'll help you. First of all, you know how to blow up a balloon.
Yeah.
Okay. I'll put the two glasses like this, and you put the balloon between them, and I'll hold them like this, and you blow up the balloon.
Okay.
Keep blowing. Hard. Hard. One more. Okay, now pinch the balloon. Now raise the glasses. It worked.
I don't think it would work.
Why does it work?
Because the balloon blows up in front of the glass,
Right.
inside the glass.
Inside the glasses and
lifts them up.
squeezes against them. You
Yeah.
can see why I use plastic glasses too, can't you? Yeah. Because let go of the balloon once, watch what let the air.
Oh.
So that's a good trick you can try on your brother.
Okay.
This newly born chick is one of the rarest birds in the world, a Puerto Rican parrot. Scientists believe there may be fewer than 20 adult birds left in the world, all in a protected forest in the mountains of Puerto Rico. A few hundred years ago, there were thousands of them in the forest. Then the land was cleared for farming, and the parrot population declined rapidly. Why? There was still plenty for the birds to eat, so food was not the problem. The biologists found that parrots prefer to nest in holes in trees, but the holes must be just the right depth and not too wet. This is the pearly-eyed thrasher that nests in the same kinds of holes as the parrot. It pecked at what it thought was a parrot egg in the nest, but it's a fake. You see, once the biologists discovered that thrashers take over the parrots' nests, they removed the eggs to hatch them in the lab. Both the thrasher and the parrots were fooled by the artificial eggs. Eventually, the hatchlings were returned to the nest and raised by their parents. After many trials, the scientists developed an artificial nesting box tailored to the parrots' liking, but not to the thrashers. But the parrots have other natural enemies. Several types of hawks prey on the fledglings, and one species attacks the adults. A tree-climbing snake also hunts the young birds. If this fly lays its eggs on the young birds, the maggots that develop may kill them. The biologists saved many birds that were infected with the maggots. Even bees can present a problem if a swarm moves into a parrot's nest. With an aerosol spray, the bees are frozen and removed so the parrots can reclaim the nesting site. After much study, the biologists decided that since it was very difficult to control the parrot's natural enemies in the forest, they would try to raise the birds in captivity. The eggs will be hatched in an incubator and the chicks cared for until they're old enough to be released into the forest. With man's help, the future may show an increase in the numbers of one of the rarest birds in the world, the Puerto Rican parrot. Or here's a ruler, and I've drilled some holes in them, see? And one hole at the end there, I can slip over that nail and cut the top off the nail so the ruler will go like this. Now, here are 2 washers. One I'll place right here on the edge, and the other one I'll place out here like this. When I flick the ruler like that with my hand, the ruler is going to be jerked out from under this one, so where is it going to go?
It's going to go straight down.
Down. But the ruler will hit that one. Where will that one go?
Over
out there
here.
someplace. Hopefully I can keep it on the desk. But the important thing is, which one will hit the desk first?
I think that one will, because this one will be busy going over here, so
Okay.
it'll take longer.
So you stand over here now and turn on your ears good and loud. You ready?
I think both of them did it at the same time.
Okay, let's put this up here again. When this ruler is jerked out from underneath him, when this starts down, not like that, but when the ruler goes out and it goes down, what's pulling it down?
Gravity.
Thank you for that. What's pulling this one down when it's going down over here?
Gravity.
Does it make any difference whether this one is moving? Gravity is still going to pull down on it, isn't it?
Yeah.
Yeah. So why shouldn't they hit the table at the same time?
I don't know.
Well, they should. They should. In fact, that's what you said, and you were right. Because gravity pulls down on something even when it's moving. Okay, so you can try this at home if you like. Just drill a hole in the end of a ruler, put a nail on it, and get a couple of washers, and you can do a famous scientific experiment. Karen, without hurting yourself, I'd like you to try to pick up this pail full of stones.
Looks very heavy.
There it is, right?
Yeah, I could say.
Well, before you finish, you're going to be able to pick it up without any trouble at all.
How?
Well, because of a thing called mechanical advantage. And the help of a little rope like this and a gadget like that. Have you ever seen one of those?
Yeah, I was going on a ferry and it was loading a barge and it was really neat because they had this great big pulley
That's
attached
what
to
that's
a
called.
winch.
What is a pulley, you know?
Well, it's a thing that helps distribute weight, I think.
Well, the point is that it's a gadget like this where it has a bunch of wheels inside. Okay. Well, I've now strung the rope over one of the wheels inside the pulley, and I'll tie it like that, and you pull and see if that helps any.
No, it's harder to lift.
Well, that's because you can't grab onto it as easily as you can the handle of the pail.
Yeah.
And notice that all you did was change the direction of your pulling.
Yeah.
Before, how were you pulling?
Up.
Up. Now, how are you pulling?
Down.
Down. Okay. So now we got to get more help from the pulleys.
Okay.
I'll undo this, and you see that one lying on the ground down there in front of the pail?
Yeah?
You want to hand that to me, please?
Sure.
Okay. So hold on to that. And I'll now put it through one of the wheels of this pulley. Now, hang on to that. And I'll tie it up here. Okay, now.
Oops, sorry about that.
Okay, now, pull. Still can't lift it.
No.
Okay. But notice, by the way, that we now have 2 ropes pulling on the pail.
That should make it easier, but
Should make it. In
isn't.
fact, it does make it easier, but it's still too hard for you to do. If we get help from 2, how many wheels are there in this one?
There's 3.
How many wheels in that one?
3 again.
So if we make the rope go back and forth, how many will we have?
6.
Yes. Then you should be able to do it. So we have to start over and restring the pulleys. You got that one? Hang on to it.
These pulleys are fairly old, aren't they?
Well, how old are you?
I'm 11.
Yeah, well, they're twice as old as you are then. I guess that makes them old.
Not really. They're not.
By the way, how
young.
many have I got?
You got 2 now.
And now?
You've got 3. And there's 4. No, that's 5.
5.
And there's 6.
And there's 6. Okay, go ahead, pull, see if it's easier.
Oh yeah, this is cinchy.
Cinchy? Okay, now put it back down again. Because it was a lot easier for you to do, so you got that mechanical advantage. Remember when we started, I told you we're going to get a mechanical advantage, but you don't get something for nothing. You had to give up something in order to get that mechanical advantage. You know what you gave up?
No.
Okay, well, see that stake I have on the ground there with the red mark on it?
Yep.
This time I'd like you to raise the pail so the bottom of the pail is even with that red mark.
Okay.
And on the rope, you notice I have red marks also?
Yeah.
Well, what I'd like you to do is to count the number of red marks, because the distance between that red mark and this red mark is the same as the distance from the ground up to that red mark.
Oh, okay. I
Okay,
understand.
so now
Okay, now does this count as 1?
that would be 0.
Okay, 0.
That'll be 1. Okay.
1, 2, 3, 4, 5.
6.
Yeah.
Right there. 6.
6.
Okay, good. It came out just as I had hoped it would. So what did you have to give up? How much distance did the pail go through? Only one of those things.
Yeah.
How much did you have to pull?
6.
6 times as much.
Yeah.
So you had to give up distance.
Oh, okay. I
right?
see.
You gained a mechanical advantage of 6 times for getting the friction in the pulleys. And in order to do that, you had to go through 6 times as much distance.
Yeah.
Okay, so can you let it down?
That's neat.
So how come you were able to lift the pail?
Mechanical advantage.
Right. Modern abstract art being created before your very eyes in much the same way as frost forms on a window. But these are crystals of sodium thiosulfate, the chemical photographers use to fix negatives in prints, and which they call Hypo. The Hypo solution is on a slide under the microscope and illuminated with polarized light. As the solution cools, the crystals begin to grow, like frost on a window. As you see a change from one color to another, it indicates a difference in thickness on the order of millionths of a millimeter. Note that the angles at the growing tips are all the same. That's characteristic of sodium thiosulfate. The study of crystals and how they grow has given you radio, television, the pocket calculator, man-made gems, new drugs, stronger iron and steel, sonar, ballpoint pens, computers, and much, much more. As researchers in laboratories look through their microscopes, they often see the electrical properties of atoms and molecules producing the modern abstract art of crystals. A while back, I glued these 2 pieces of paper together, Michael, and I'd like you to tear them apart.
Okay.
Go ahead, just keep going. See how strong the glue was?
Uh-huh.
The paper tore before the glue gave way. And I made that glue myself,
You
right
did?
here in this very kitchen,
How'd you do that?
out of skim milk.
Skim milk.
Yes, most people don't realize there are solids in milk. That's one of the reasons why you drink it, to get the protein.
I see.
I have some cooking over here on the stove.
Okay.
Do you know the poem Little Miss Muffet?
Yeah.
Okay, would you recite it for me, please?
Okay. Little Miss Muffet sat under tuffet, eating her curds and whey. Along came a spider and sat down beside her.
And frightened
Little Miss Muffet away.
All right. Now, what was she eating?
Curds and whey.
Curds and whey. Have you ever seen curds and whey?
No.
Well, we're going to make some. Here's some vinegar, and I have warm skim milk, about 2 cups or so. Pour a little in there, and I'll stir it for you.
Okay.
Oh, that's enough. Let's see if that'll do it.
What's it? Oh, it's
Okay, that's enough.
lumping.
Keep stirring it.
okay. She ate this?
Yep, that's what she was eating. I'll pour a little more in just to make sure that we...
She actually ate this?
Yes, she actually ate. Those are the curds. You know when milk sours, it's curdles?
Uh-huh.
Okay, well, that's what you just did. And what's left behind is the whey. Okay, I'll turn the stove off now. Bring that over here to this bowl and pour it in here so we can separate the curds from the whey. Just go ahead, pour it in the sieve.
That kind of stinks.
Well, that's because of the vinegar.
That's disgusting.
Why?
Why would she eat that?
Well, put it back on the stove over there, wait. As a matter of fact,
she
you
hungry or something?
Yeah, she was hungry, but you've probably eaten some of it yourself. Because if you make this in a slightly different way, that protein becomes cottage cheese.
Oh, I see. Well, I don't like cottage cheese.
You don't like cottage cheese, okay. Now we put acid in there. Now we want to neutralize the acid. So here, put a little sodium bicarbonate in there and mix it.
How much?
Oh, half a tablespoon, and stir it all up.
foaming.
Why?
Well, that's probably the chemical reaction.
Right, between the vinegar and the baking soda. Okay, now let's say we want blue glue. All you have to do is add
Some food
a
coloring.
little food coloring. Ooh, that's more than a little. So if somebody run out of glue and you got some skim milk around the house, you can certainly make very strong glue. In fact, some of the white glue that you buy in a bottle is casein glue because it's really very strong. And they've used the same kind of casein, which is what that protein is called, to make buttons and various other artificial things. So let's glue some pieces together. Here,
Okay.
put a little blue glue in the middle of that. Boy, we made a mess. Oh, well.
Clean it up later.
Yeah. Give it a good pounding. And there's the kind of glue you can make. And here, when you let it dry, it turns out like this. Go ahead, tear it and see.
That is very strong.
Yeah, very strong glue out of skim milk. AJ, here's a challenge for you. See the materials sitting there on the table? I want you to make them into a record player.
That's impossible, making it out of a pencil, a pen, some tape, and a piece of paper.
Well, not really. And here's the record that I want you to play. Well, how does an ordinary record player work? What do you need?
You need a turntable with a motor, turns it around, a needle.
Right, needles in there.
Sends vibrations down into an amplifier, and that projects the sound out into a speaker.
Okay, that's what you need right there. I assume that you can get a clue what the pin is going to be used for.
That's for the needle.
Okay. Then I would like you to take this piece of paper and roll it into a cone.
Okay.
Okay. Can you open it up a little more now? Okay, here's a piece of tape. Tape that in place. Now, to the end of the cone, the pointed end over there, attach the pin
Okay.
sticking out over the edge. Okay, there's the needle in the amplifier.
Oh, wow.
If you vibrate the needle a little bit,
Well, then there's noise coming out here.
well, it vibrates the whole piece of paper, and that amplifies it. So that's our amplifier.
Okay.
Okay, now I need a turntable. You want to hold that for a minute?
Sure.
The pencil is just about the right size if you add a little tape to it to stick in the hole of the record player, of the record.
Oh.
And then you can spin the record like a top.
Well, maybe it's just a
There's
bit
So I'll be
wavy
the
up
motor.
and down.
Well, that's because I haven't got it on real straight. But if you now hold the pin in the groove and listen.
Well, she swallowed the cat to catch the bird. She swallowed the bird to catch the spider that wiggled and jiggled and tickled inside her.
So if you're going to do this at home, what do you need?
Piece of paper, some tape.
What do you do with the paper?
You roll it into a cone,
Yeah.
and you tape it down.
Yeah.
And then you tape a pin down. That's another thing you need is a
Right.
pin. And then you need a pencil with a little bit of tape on it. And a record player. And a record.
And a record. And I would suggest that you not use your best records.
Yeah.
Because that needle, the point of that pin sort of ruins this at the same time. But at least
Yeah.
you made a record player and accepted and won the challenge. Congratulations.
Thanks.